Rose curves. A rose curve is going to be something of the form r equals a cosine k theta, or r equals a sine k theta, where k is a number like 2, 3, 4, or 5. So for example, r equals 52 cosine 3 theta, and r equals 1/4 sine 4 theta. To graph these, we're going to do a lot of preparation before we do the actual graph. So for example, I'm going to draw a guide circle, and I'm going to label it r equals 52. That's because the largest that r can possibly be is 52, and that happens when the cosine is either positive 1 or negative 1. If positive 1, then in that direction it would reach out and touch the circle. If cosine 3 theta was negative 1, then in this direction it would reach backwards and touch the opposite side. Next, I'm going to subdivide each quadrant into this many pieces. So with the term being 3, I'm going to subdivide each quadrant into thirds. Think slicing a pizza. Now the pattern that I'm going to use is the pattern for cosine, but now the pattern is going to start 1, 0, negative 1, 0. Remember that this is pi over 6, but when I triple pi over 6, I get pi over 2, and the cosine of pi over 2 is 0. This is pi over 3, the direction pi over 3. When I triple pi over 3, I get the cosine of pi, which is a negative 1. And I'm going to continue this pattern around the spokes of my wheel. 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0, and it would continue 1, 0, negative 1, 0. Whenever the cosine of 3 theta is 1, it's going to touch that edge. Now remember that this stands for r equals 52. So when theta is 0, I've got the cosine of 0, which is 1, and r is 52 times 1. By the time that I'm pointing at the pi over 6 direction, it will have returned to the center, the pole. Whenever cosine is 0, r is going to be touching the pole. So initially, I'm going to be following this curve, coming in along this line. In this zone, from pi over 6 up to pi over 2, cosine is going to be negative, which means that I'm going to have to be drawing behind me. If I go in the pi over 3 direction, I would have 52 times the cosine of pi, so that would be a negative 1. So facing this direction, I have to go backwards 52. So I have to, as I'm moving from here, from this direction to this direction, I'm going to be sweeping through and touching. Next I hit 0, so I return. 1, I touch the outer edge. 0, I return. Negative 1, I hit the opposite edge. 0, I return. 1, the outer edge. 0, I return. Negative 1, the opposite edge. 0, I return. 1, I hit that edge. And so as I've spun around through my full 2 pi's worth of rotation, I will have traced over this graph. If r equals 1/4 sine 4 theta, don't bother making a tiny graph. Draw the circle, about the same size, but now I'm going to label it r equals 1/4. Subdivide each quadrant into 4 pieces. I find it easiest to cut in half, and then to cut each of my halves in half. So cut in half, and then cut each half. in half. So this really stands for pi over 8, pi over 4, 3 pi over 8, and pi over 2. The pattern for sine is going to be 0, 1, 0, negative 1, 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 0, 1, 0, negative 1. The same pattern holds with this rose curve. If the outer spoke is labeled as 0, that means that sine is 0, and r would be 1/4 times 0. If the outer spoke shows a 1, that means that r would be 1/4 times 1. That means that r would equal 1/4, and I'd be at the outside of the circle. 0 means a return. Negative 1 means that it's going to touch, but on the opposite side. 0, I return. 1, out to the edge. 0, return. Negative 1, opposite edge. 0, return. 1, out to the edge. 0, return. Negative 1, opposite edge. 0, I return. 1, out to the edge. 0, I return. Negative 1, opposite edge. 0, I return. If I count the number of leaves, this time I have 1, 2, 3, 4, 5, 6, 7, 8. If k is an even number, I will end up with twice that many leaves. So in this case, I would end up with 8 leaves in my rose curve. If k is odd, I end up with exactly that many leaves, but I would retrace over them. Now the reason for this is that if you look on the odd graphs, the ones and the negative ones will be opposite, which means that when I'm facing in the direction of the 1, I go out to that edge. When I'm facing in the direction of the negative 1, I go to the opposite edge, which will be a retrace. On the even graphs, if k is even, then notice that the 1s are opposite of 1s, and negative 1s are opposite of negative 1s. So when I'm facing in this direction, I draw out to this edge. When I'm facing in this direction, I draw out to this edge. When I'm facing in this direction, I come back to the opposite edge, but now when I'm facing in the direction that I've just indicated, I graph at its opposite edge. So I'm always going to touch at the 1s. I'm also always going to touch opposite of my negative 1s. But since the negative 1s are opposite of each other, I'm also going to touch at the negative 1s. These are rose curves. For rose curves, I will typically give values of k that are either 2, 3, 4, or 5. We could graph higher, but these are the essential rose curves. These are the ones I want you to look at the most.